Hi, I'm CJ and this is my RC channel. I wanted to show you what comes in this box. This is the Chrysalis-Lite 2 meter by DJ Aerotech. I apologize if there's a little buzzing in the background. That's the ballast of the fluorescent light that I've got hanging over my head. I may have to replace that. But it is making a big difference in lighting. I highly recommend having a light that is hung over your head and maybe a little bit behind you. That way you don't have lighting that's coming from in front and casting shadow. You can miss fine detail that way. Just thought. So as I said, full-sized plans. This is an interesting fuselage. The design is kind of the opposite of what you would normally expect. It is wide versus tall, so the servos lay flat on their sides, it's just an interesting shape. I like it. I think it looks good, and I'm looking forward to the build. I don't know why they chose that as far as strength, or whether there's an aerodynamic factor going on there. I do not know. I've talked to one of the gentlemen who designed this, and I'll ask him some more questions down the road. And if you have questions, please free to put them in the comment section, and I'll see if I can get answers. So, what we have is a three-piece wing. There is a flat center section here. This may or may not have some dihedral in it. I don't know yet. Haven't gotten that far into it. I doubt it does. I'm guessing that there is dihedral at either side of this center section where the two outer sections plug in. And I'd be willing to bet there's dihedral here out at the wingtips. So that would be 4 points of dihedral and a three-piece wing. The reason for the center section is that there's going to be a spoiler, which is probably about this size right here. That's a panel that flips straight up into the wind. I've built gliders in the past that had spoilers or pop-up air brakes, and those things really slow a plane down when it's coming in for landing. They can be really nice. Different than flaps, similar effect. You don't get the ballooning with flaps, and with flaps you can tune them to give you more lift or kill the shape of the airfoil to give you a lot of speed. There's a lot of advantages to flaps, but then again, that makes it for a more advanced airplane. And the rudder elevator spoiler spec for 2-meter glider competition was designed around planes that anybody can build and that anybody can fly, and that they can do it with an inexpensive radio. They don't need a high-tech programmable radio. A simple basic 4-channel would serve just fine. Pardon me while I roll that up. Okay, so let's start into the box and see what we've got here. Right off the bat, we have these two. I'm not gonna fiddle with these right now. I'm not sure if these are wire or if this is a thin carbon fiber or some other material altogether. It doesn't feel like metal. It's very flexible. These are going to be the push rods for the rudder and elevator. Everything is very well packed. For example, this is a very thin sheet of balsa between these pieces of cardboard here, and as you can see, there are little laser cut pieces in there. Everything is laser cut. As you can see here, we have a bunch of plywood pieces. These look like our the parts to where our wings are going to hold together. These are the carbon joiners. Looks like there's some nylon there, magnet, that's probably for the hatch. More pieces that look like they're hardwood, all laser cut. Just some balsa. There's obviously going to be some carving that needs to be done, so having a razor plane, if you do this kit, would be a good idea. This is definitely not a complete beginner's kit. I mean, if you've never built anything before, you know, you never did even wind up planes, this may or may not be where you want to start. I'll address that later. From what I've seen of the instructions, especially if you have anybody to give you any guidance, pretty much anybody should be able to do this. Okay, these are some doublers. Very thin, that looks like 1/64 inch ply. This looks like 1/32 inch ply. These look like they are for the sides of the fuselage. This looks like the bottom of the fuselage. These are the trailing edges for the wings. They're notched, which is very nice, so that the wing ribs are going to go into those notches. It gives you a better attachment point. Everything is very purpose-built, as you can see. It looks like they've you know, tried to lighten everything they can where they can. There's a great variance in the thicknesses of the wood and the types of wood used. And these are, looks like 1mm plywood. I would assume these are for the more structural parts of the wing, where the wings are going to join together. That's why we have these round holes here. But there's lightning holes in these spars. Got to be careful about this. Things are starting to drop out. And again, we have some stiffer wood. This looks like this might be spruce or bass wood. And here we have some nice thin. These ribs are very thin. That's 1mm at most. And again, everything is laser cut. I am not going to pull this out because there's nothing beneath that. So I'm just going to put this in. As you can see, everything is lettered. And if you recall, on the plans, each wing spar on the plans was lettered and detailed and marked, just like these are all marked. Yes, I think a beginner could put this together. It would take patience and following the directions carefully. But if those two things came into play, yes, a beginner could do this. I mean, there's a lot of parts, so you want to follow the instructions and do a step at a time. Don't try to do too much in a day. Don't have the hobby king mentality that I'm going to build a plane in 30 minutes and have a piece of garbage at the end. This looks like it is going to be a nice plane. Here is some sticks. These little dowels here are going to be the leading edges for the wing. These little tubes are for our push rods. This is a very, very thin material here and very light. So it's really nice that they're doing something specific. They're not just using off-the-shelf stuff like good old golden rods. You know, if I were building a 2-meter plane, I'd probably just get golden rods, and you know, they are light enough, but this is super light. This is a competition plane, and our carbon fiber boom. So that, my friends, is what comes in the box. So I'm going to carefully put everything back, and you'll see all of this stuff as the build progresses. So now I'm going to talk about all the other stuff you need, because there's always other stuff needed. Now, they recommend specific hinges. Go ahead and set some of this stuff aside. And they also recommended some battery size on those. And I am pretty much following their lead on that. Slight change. Okay. So they recommended these 3 servos. They're all Turnigy servos, rudder, elevator, and a slightly smaller servo for the spoiler. And let me hold these up for you. So 2 of these. And there's the part number if you want to look these up. You can find these on Hobby King. And 1 of these for the spoiler. And as you can see, these are very, very small servos. And the only thing I didn't like about the rudder elevator servos is the fact that they are all plastic gears. And for control surfaces, if you've watched my videos in the past, you know that I like metal gears. These are what I'm going to be using. I went ahead and got these for demonstration purpose. This is actually a smaller servo. You'll see them up close. I'll actually weigh them. Let me see if I can get some specs off of here. As I recall, these were a little torqueier than these, and I'm going to try to run them at their max 6 volts of voltage. So I bought a pair of these. They were not much more expensive. All of these servos are in like the $7 to $15 range, not very expensive. So I did deviate with that. I did not know what type of wing joining system they had. They may just recommend taping the wing. This is a type of wing joiner system. You have these little threaded plugs, and you put this into one surface of the wing, and then you screw these guys into the other side, and these basically plug into these like a male-female configuration. And you might just need one of them on each side to snap in and hold the wings together. It comes with this little wedge that you use to separate the wing. You slide it in between the 2 wings and pop this out. As you can see, this one is notched and is slightly has a little bit of a lip at the edge, so that's going to click in. And I bought a pair of these. I wasn't sure if I was going to use 1 or 2. I wasn't sure if I was going to use them. I may use them on something else. So here's what it is. You can see the name and the model number if you want to go look for these. I found these on espritech.com, ESPRITTECH. And I didn't know what was going to be included in the kit as far as a tow hook. So I bought a light adjustable tow hook. Now, having delved into the instructions and stuff, there is an adjustable tow hook setup in the kit that they designed, and I'm going to look at how that goes together, and I'm either going to use the one that they provide, or I may add this to the kit. This is very light and it's very easy to adjust. You just loosen the screw, slide this forward or backwards, tighten it down again. So I'm going to see which one of those I end up using. Also, I didn't know if they had a specific hatch cover method in mind. Looks like they're going to be using magnets. This is a little cabin latch. There's a pin here that is spring-loaded. It's already made. You can just, as you can see, pull that back and release. And you attach this to the bottom of the side of the hatch with a little slot above. So I will decide which way to go with that. I may just save this for another kit down the road. I got a Orange RX 7-channel receiver. And that is compatible with Spectrum. And of course I got more connectors. In the same way that I may be using these, instead of having male-female pins where the wings join together, I may glue a male and a female of these connectors in each of the wing sections, so that the two outer sections will plug in, and I won't have to fiddle with JR wire connectors at the side of the wing as I'm putting the wing together, just where they connect to the fuselage. And may even do that in the fuselage as well. Since it's a single center section, I could put one facing up, and a female facing up and a male facing down, or vice versa. And then when the wing is placed on top of the fuselage and screwed in place, it'll automatically connect. That's an option. Let's see, that's not relevant. This is a Spectrum variometer. It works with Spectrum's telemetry features. Variometer is an altimeter, so it will let me know if the plane is rising or falling, so I'll know if I'm in lift. May not be able to use this in competition, probably not, I don't know. But certainly as I'm learning the plane and I'm flying it for sport and fun, and I want to be able to recognize when I'm getting lift, this will help me identify it, because if I see how the plane reacts, how the wing, twitches in the wind, and then this thing starts beeping away that I'm rising, okay, great, that's what the plane looks like when it starts getting into lift. This is, you may have seen these in past videos. I like these a lot. This is a Castle BEC. It's independent BEC. There's no speed control. This just is a battery elimination circuit for any type of aircraft, and it's designed to work with a variety of LiPos in various sizes. One of the nice things about this is that it has a 10 amp peak, and it has a pretty broad spectrum of output. You can set this anywhere from 4.8 volts, which is about as low as most servos go, up to 9 volts. Now these servos have a max voltage of 6 volts. That's going to let them have their peak torque and their peak speed. So I will probably be setting this up to run at 6 volts. And I bought 2 small LEDs. Now if you looked at that fuselage plan that I showed you earlier, if you recall, it's very thin, it's not very tall, it's more wide. And they had some recommendations on batteries, and I went with this particular battery. It's in the range of what they were suggesting. It's a little smaller and not quite as powerful, but I have 2 of them, so I can swap out as needed. And one of the reasons I went with this was the power to weight over the other batteries, since this is going to be a competition glider. I'm trying to minimize weight and maximize performance. Now, ideally, I want to build the kit to be as light as possible. As I'm building, I'm going to move gear around, you know, figure out battery and servo placement and receiver placement, and try to do that in such a way that I don't need to add much ballast to get the plane to balance on its center of gravity. Okay, now if it's a very windy day, I may need to add ballast so the plane can penetrate better into the wind and not just be a kite. If you've flown gliders, you're familiar with that and you understand, but when you're doing the basic build, you want to make it as light as possible. So if you are flying on a completely flat day where there's very little wind and not a lot of lift, you want it to be as light as possible so that you can take advantage of that nice big wing loading and have as much duration as possible. This is something that I may put in here depending on where I'm flying. If I'm flying in a really large, really flat area, I may not bother with this. But if I am flying at one of the fields I fly at that has a nice big tree line that loves to gobble down airplanes, and I got an interesting story to tell you about that another time. This is an alarm finder, and there's two in this bag. You can plug it in line with a servo or into an empty channel. So it has a male and a female, so it can be in line. And what this is going to do is, if you turn off your radio or if you lose signal and the battery the battery is still connected, it's going to beep away and make a lot of noise and help you find your plane. Now, again, weight that is not necessary to add necessarily, but I mean, these things really weigh next to nothing. I mean, this bag, the cardboard at this end is almost as heavy as these at this end, and there's two of them plus the plastic bag, so not a big thing. And I have one last thing that I'm probably going to add. This is a satellite receiver. Some of you may have heard of these. You may have seen them when you're looking online at different receivers, and you'll see a receiver that comes with a satellite receiver, and you're thinking, okay, that's odd. Is that going to like contact satellites in space, like, you know, a sat phone or something? No, it's not. Satellite, the word is used in the relationship between the receiver and the primary receiver and the satellite receiver. This is a satellite to this. It's the relationship. So what this does is, these are particularly useful with carbon fiber planes that have a lot of carbon or thick fuselage material that is getting in the way of your radio. Older wooden planes, you don't see a lot of antennas sticking out usually. Foam planes, you don't usually see a lot of antennas sticking out. But with more modern planes, and especially if you're going to be flying at distance, you want to make sure that your radio has line of sight on one of the antennas. So with this receiver, let's just say that this is the fuselage, and here is this receiver, and it's got two antennas sticking out left and right like little whiskers, you know, sticking out about 1.5 inches, 2 inches. That's all they really need. This satellite receiver can be mounted rearward behind the wing and vertically, so that these little whiskers are sticking downward and upward out of the fuselage. And what that allows for is that the plane can be facing away from you and in a bank where the wings are basically blocking line of sight to these little whiskers. That isn't necessarily going to be a problem, but that's how you end up losing communication with a plane, especially if there is a full carbon fiber fuselage that isn't 2.4 gigahertz friendly. And even if it is, 2.4 gigahertz friendly, probably a good idea to do this kind of thing anyway. Since I'm going to be flying this plane in competition, there's going to be a lot of RF signal in the area, lots of people firing up radios. I'm going to be probably building this into the airplane in the rear of the fuselage near the tail boom, so that where that's thinner, and have one of these whiskers pointing up and one of these whiskers pointing down through the fuselage, so that I have the best signal strength and connection possible, regardless of the attitude position of the aircraft, and within reason how far away. So that pretty much covers all the little doodads that I'm going to be using. Now, just as a must-have list. Okay, well, you must have a receiver. You must have at least one battery. You could live without these and just use connectors. You must have 3 servos, and they don't need to be metal. You can go with their recommended numbers. You do not need the cabin latch, this fancy little spring latch, which costs about $7. You can use the magnets that they provide. I did not know that they had magnets, so I'm going to make a decision on that. Likewise, you do not need to buy your own tow hitch. They do provide one. It's in the kit, and it is adjustable. You do need a BEC if you are using a LiPo. Now, you don't have to use LiPos. You could do this. You could just use a standard AA battery pack, or you could do what I did with the Raven 1500. I used a battery pack that is not LiPos, it's NiCads like these, but they are AAA size, and they are mounted 2 and 2. So the battery pack is long and thin, and that would be ideal for this particular fuselage because it is very thin. This fuselage might be able to handle a 4-stack, this configuration of AAAs. It'll certainly handle the LiPos. The main thing with the LiPos is they are a fraction of the weight of the NiCads. And this LiPo is still probably lighter than the AAA NiCads. So, always thinking about weight. But then again, if you're using this, you do not need to add the BEC. This is going to provide just the current you need for your receiver. But this is 1.2 volt batteries, so you have 4.8 volts. That is the minimum voltage for these servos, for any servo. So you don't get to amp them up to 6 volts as you can if you use the BEC and program that. So all things to consider when you if you spec this kit out and you want to buy it and you want to build it. So things like the altimeter, not necessary. They seem to have good luck flying with these plastic geared servos. You do not necessarily need to upgrade to the metal gear servos. Let me hold this up close enough so you can see the number on these. These also came from Hobby King. The difference in price between these metal gear servos and these plastic servos is negligible. It's probably less than $3 or $5 each in difference in price. These are smaller, they're thinner, they're about the same height and width, but the thickness, they're thinner, and they're stronger. You're not going to have one of these things break on a something, you know, hitting the rudder on landing. Or anyway, I've just heard of plastic gear servos, you know, wearing out on people, the gears tearing, you know, you get a stuttering surface. And if that happens, I mean, can you imagine having your rudder, like, you know, barely function, and you try to give it full right, and it doesn't go a little bit, it goes all the way out, and then kind of clicks in place and snap, 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 and then doesn't want to return. Horrible. So, you know, I just feel safer flying with metal gear servos. It's just one more thing that is not going to go wrong. Up to you. It's your appetite for danger and destruction. Anyway, I hope you enjoyed this video. I hope you've learned something. I try to go into more detail than less for the people who are new to the hobby. I apologize if you're an old hand and I'm boring you with a lot of unnecessary information. So be it. Please click like. Please subscribe to my channel. I need the support. The more people that subscribe, the more community that I can build around this site, the more likely I can continue providing you with these types of videos. This is something I'm doing completely out of my pocket, and I'm not a wealthy man. So I'm doing this purely for just a desire to build fun kits and to teach people. That's one of the things I did as part of my career, was teaching, and I like to build at least as much as I like to fly. So I'm trying to pass something on to the hobby. Well, that's all for this video. In the next video, I'm going to start building.